Welcome back to this lecture series on my new book, Artificial Intelligence, Neurodata and Society, Law at the Edge of Cognition, by me, Dr. Mark Leiser. Chapter 1 of my book states the book's central provocation in its clearest form. Artificial intelligence increasingly operates upstream of action. It no longer needs to wait for a person to speak, click, purchase, or decide. Systems trained on neural signals and on proxies calibrated against them can model emotion, hesitation, intention, and susceptibility while those states remain unarticulated. The chapter does not claim that a machine has achieved transparent access to a fully formed inner monologue. Its argument is more careful and more consequential. Probabilistic inference can become operational before conscious recognition. Once institutions act on those predictions, the machine acquires practical authority over the conditions in which judgment forms. This lecture follows the chapter from the loss of mental opacity through the technologies and commercial strategies enabling NeuroAI to the question where law can protect mental sovereignty before influence becomes normalized. The intellectual move on this side is crucial. Inner life once enjoyed a form of protection because it was difficult to reach. Law did not necessarily build a complete wall around preconscious thought. Epistemic limitations supplied much of the wall for us. Feelings, emerging intentions, and internal conflict remained available primarily through first-person report or inference from outward conduct. NeuroAI weakens that practical shelter. Neural measurements, behavioral traces, and biometric signals can be mapped against labeled cognitive states across populations. The result is not certainty, but a new kind of legibility. Systems can identify patterns that correlate with what a person may be feeling, recognizing, or preparing to do. The legal question is therefore not only who may collect brain data, it's who may convert probabilistic insight into action, how that insight can be challenged, and whether the subject retains authority when a system claims to understand the mind earlier than the person does. The vignette in this chapter focuses on Sophie and the upstream turn. Sophie's story makes the upstream turn vivid. She experiences only a faint disturbance in her relationship, not yet a belief, an intention, or a decision. The model, trained on her neural responses, gives that ambiguity a name before she can. It concludes that the relationship is ending. The scenario is powerful because it stages an epistemic rivalry. Sophie's account is tentative, embodied, and narratively unfinished. The system's output arrives at an externally validated insight. Even if the prediction proves accurate, the problem does not disappear. Accuracy may intensify it because the system's foresight can harden into a story about who Sophie is and what she will do. The subject becomes retrospective. She encounters her own mental life through the model's prior classification. The chapter therefore asks us to distinguish privacy from temporal authority. Who has the legitimate right to interpret an emerging mental state first? And what happens when the machine moves before self-understanding? The technologies on this slide provide different forms of access. EEG captures electrical activity with excellent temporal resolution, making it attractive for attention, recognition, arousal, and rapid response detection. fMRI sacrifices speed for spatial richness, allowing models to associate distributed patterns of blood oxygen activity with visual, semantic, or affective content. Brain-computer interfaces create a more direct route between neural activity and external systems, translating motor preparation or other signals into commands. The chapter's emphasis, however, lies beyond the device. Large action models can connect perception to execution. When a system receives a stream of neural or neuro-calibrated signals, it can select actions, test responses, and adapt the environment in real time. This is why the stack matters legally. The sensor does not merely observe. Joined to machine learning and goal-directed action, it becomes part of an architecture capable of intervention while cognition remains in formation. The chapter deliberately expands both definitions shown here. Neuroprivacy cannot mean only the security of a file containing EEG or fMRI readings. It concerns the conditions under which mental states remain insulated from systematic inference, prediction, and intervention. That definition reaches direct neural collection, but also behavioral and biometric proxies when systems use them to render cognition legible and actionable. Neurodata, likewise, is not merely another static biometric identifier. It includes measurable nervous system signals and derivative representations that support inference about cognitive or affective states. Its significance lies in temporality and function. It can model how thought is forming rather than simply identify who a person is. This is where mental sovereignty enters. Privacy protects against unwanted access. Sovereignty protects the subject's constitutive authority to interpret, understand, and disclose mental life. The law must therefore ask not only what data a controller holds, but what power the resulting model exercises over cognition. Chapter 1 never denies the therapeutic promise of these systems. Earlier seizure warnings, communication for people with paralysis, responsive mental health support, and better assistive interfaces are serious benefits. The difficult point is that cognitive insight travels. A model trained to recognize fatigue, distress, or declining executive control can later inform workplace monitoring, insurance, policing, or commercial optimization. Once the correlation has been learned, the secondary actor may not require the original neural record at all. A gaze pattern, a voice change, or hesitation may serve as a proxy. The distinction between diagnosis and manipulation therefore turns less on technical capability than on institutional purpose and power. A system that adjusts an environment to support the user may look structurally similar to one that exploits susceptibility to secure engagement or purchase. The chapter insists that regulation must confront this portability rather than assume that a benevolent origin will keep the inference benevolent. The discussion of Facebook's acquisition of Control Labs is important because it reveals a commercial direction of travel. Publicly, neural wristbands promise frictionless controls of augmented and virtual environments. Strategically, they also promise data about intention before conventional interface action. That is valuable to a platform business because prediction becomes faster, personalization more intimate, and control less dependent on explicit commands. The chapter does not rest its argument on one company or one product surviving its original form. Indeed, direct brain sensing may create reputational and regulatory friction. The deeper logic can migrate towards indirect signals in ordinary devices. What the acquisition made visible was a commercial imagination in which neural or neuromuscular activity becomes another stream within the platform's optimization architecture. The frontier is not simply hands-free input, it is the incorporation of pre-action signals into systems designed to anticipate, personalize, and influence. My second vignette in this chapter focuses on a character named Malik. Malik has decided not to buy. The system infers cognitive load, arousal, and a pattern associated with impulse purchasing under stress. It then changes the lighting, sound, timing, and the presentation of the offer. Nothing on this slide resembles classic coercion. No threat appears. No false claim forces the transaction. The intervention works by reorganizing the decision environment at the moment when hesitation remains fluid. That is why the chapter describes a movement towards engineered alignment. Malik retains formal choice, but the system has privileged one path and softened resistance before he can identify the source of influence. Over time, a further effect appears. The subject begins to anticipate the system's expectations and regulate himself accordingly. Optimization becomes internalized. The legal challenge is acute because doctrines of deception, undue influence, and consent typically search for an identifiable act. Here, influence resides in a continuous, personalized relationship between model and mind. Chapter 1 closes by relocating the legal point of attention. Existing frameworks tend to ask whether a dataset was lawfully collected. whether a decision produced a significant effect, or whether demonstrable harm followed. NeuroAI requires us to look earlier. The decisive intervention may occur while intention, preference, and emotional orientation are still forming. Neurodata therefore cannot be treated as merely sensitive information. It becomes part of an infrastructure through which systems acquire predictive leverage over the conditions of agency. The chapter's challenge is not to abandon privacy, consent, or accountability, but to make those concepts responsive to upstream inference and environmental shaping. Law must govern what systems are permitted to model, when prediction becomes intervention, and how a person can contest an account of the self that has already reorganized the world around them. Do not forget to check out the next video in this series when we turn to Chapter 2, The Brain as a Dataset, and explore how thoughts become exploitable.